Hello, everyone. Thanks for coming to my talk today. We're going to wrap up the last few talks of the conference. I hope everybody enjoys. Today, I'm going to be talking about fakes over mocks and how, in my company at Betterment, in the mobile org, we've shifted our testing paradigm and improved both our test base and our code base along the way. So just as the few topics that we're going to be covering, we're going to start out with a very introductory look at what test doubles are and what types of test doubles exist out there and what they can be used for. We're then going to go on a journey with how Betterment's testing evolved over time and the bumps that we hit along the way and how we overcame those, and then what our pathway forward was to a healthier test suite and a healthier code base along the way. But before we get into that, who am I? I'm Caleb Donoho. I've been at Betterment for around 2 years as a mobile developer, as a Flutter developer, as a matter of fact, and I'm now shifting over into a more full stack role. Within the world of software, I really enjoy quality assurance. So anything testing, anything automation, improving the developer experience overall. And you can find me online at Celtic Majora on Twitter and GitHub. I don't post often, and when I do, it's about tabletop gaming, so probably not all that useful. Cool. And what is Betterment? Betterment is a fintech company that specializes in granting financial peace of mind to our users. We robo-advise assets for our users that allows them to reach their goals in life, whether that be retirement, having a safety net built up for the rainy day, or saving for a kid's education in the future. On the mobile front, we're a Flutter shop as of 2020. Previous to that, we were 2 native code bases, both iOS and Android. But I'll get to that again in a bit. So let's dive into the world of test doubles. To set up upfront definition, a test double is a replication of some class that's a dependency to the class that you want to test. So when we're unit testing a class under test, we want to isolate it as much as possible, such that any interactions that we have within the test are only testing its functionality rather than the functionality of its dependencies. So the first couple types of test doubles we're going to go over are fakes and stubs. These are going to be lumped together, and I might use them interchangeably throughout the remainder of the presentation, but there is a slight difference. Fakes and stubs are a real implementation of your dependency that you want to double, and they're going to have fake contents. In the case of stubs, it's going to be stub responses, meaning it's going to be a constant response anytime you call a method. In the world of fakes, they're going to try to align more closely with the dependency that you're trying to double. A good example of this might be if you have a service that makes database records and fetches those records, your fake might have a map inside of it that for the course of that fake's lifecycle can behave like a database, but in the grand scheme of things, it's not actually interacting with the database. So in this diagram here, we have a goal service. Its purpose is to fetch information about goals, and your real goal service on the left is going to be used in your production app. On the right, we have a fake goal service that we can use in the purposes of testing, and it's just going to have stubbed responses that you can inject into the constructor. This way, the fake goal service is still implementing that same interface. In the Dart and Flutter world, you just implement the base class as an interface, and they can be looked at as the same thing. So to have a corny and probably bad analogy, we can treat the goal service as if it were a man in a trench coat with glasses and a mustache, running out to a storage unit and grabbing us a box that is a goal and bringing back it to whatever screen that we're using. Our fake, on the other hand, is still going to be a man in a trench coat, might have like Groucho Marx glasses, but whenever you ask him for a goal, he's going to reach into his jacket, grab a box out, the same box every time, and that's going to be your goal. The next type of test doubles we're going to go over are mocks and spies. I'm going to talk on spies briefer because they're less important for this presentation, but spies can be a real implementation of the class that you're trying to double, but their purpose is different than a fake or a stub. Their purpose is more so to verify that certain methods were being called on that dependency. So going into the world of mocks can be used in the same verifying behavior to verify that a method was called on dependency with certain conditions, but it's not a real implementation. These are going to be using mocking libraries usually. So mockito is a common one. There's probably others in the Android world that I'm unfamiliar with. But the key thing is that they're not the real version of the thing that you're implementing. So in this diagram here, we have a test. It's setting up a mock version of this goal service using whatever mocking library you want to do. it needs to explicitly define the behavior that it wants to override on that goal service. So we have this when statement that says when the goal service gets the method fetch goal with any goal ID, we want to return a certain value. And we can do that verification that I mentioned earlier with spies and mocks, where we can verify that it was called once. We could even verify even further that it was called with certain parameters, or maybe even multiple times in a certain order with different parameters. They need to be pre-programmed with those responses. So for this example, if our class under test were to call fetch goal summaries, which was another method on that goal service from earlier, this test would blow up because the mock did not get overridden with fetch goal summaries. So let's dive into Betterment's testing journey and the issues that we ran into along the way with mocks. So back in the beginning, in January of 2020, we started our transition from 2 native code bases over into a single Flutter code base. If you want to hear more about how that happens and the technology behind that, a colleague of mine named Will Lockwood has a really good talk. You can find it on Betterment's GitHub organization profile that goes into all the technical details of how we manage that transition slowly over time. But that's not the purpose of this talk. Shortly after we started that transition, we introduced the mockito dependency to our code base, which was being used as our primary mocking library. And we used mockito for essentially every test double that we wanted to create in our tests from that point onward. There was a bombshell moment in March of 2021 where Flutter got its second version released. This is a big release. It released quote-unquote Flutter stable for web. It also introduced some new Firebase features, but it introduced the Dart language feature of null safety, which would prompt a large transition in our code base because we were coming from a previously non-null safe Dart. So we started that in April, wrapped it up in October of that same year, but along the way we ran into some hitches with our mocking. Mockito, before this transition, didn't support null safety, and even after Flutter transitioned, they didn't support null safety for a bit of a time. And once they did it through code generation. For those unfamiliar with Dart, it doesn't have all the same metaprogramming features as many other common languages nowadays. So a lot of the things that you would do with metaprogramming in other languages like Kotlin or Swift, you do through code generation in Dart. We at Betterment have sort of a hate-hate relationship with code generation, as it is a poor dev experience overall, having to wait for your code to be generated to just create a network model or routes for your features. But we still use it for network models, routes for our features, even some of the state within our forms. And those are all fine because in the end, it does speed up the development of those. And they're necessary for the end user. The idea of using mocks to just test our code code generation just to test our code was pretty unacceptable. So we started looking for an alternative because Mockito's solution was code generation. Fortunately for us, we were working with Very Good Ventures at the time, which is a Flutter software engineering firm here in New York. And one of their engineers, Felix, had developed a library called Mocktail, which did all the things that Mockito did, but without the need for code generation to do null safety. Had a slightly different interface. So as part of this transition to null safety, we began also transitioning from Mockito to Mocktail. Along the way, we experienced several bumps, though. Our first problem we ran into was our sheer over-dependence on mocks. I mentioned earlier that whenever we wanted to create a test double, we just always reached for mocks as the solution. But that's sort of unwise. In the world of software engineering, we always want to be grabbing the right tool for the right situation. So by always grabbing for mocks, we had several situations where mocks weren't the best tool, but we were still trying to cram it in there anyways. So faced up against this pressure of the null safety deadline, we realized also that Mockito, being the broad reaching dependency that it was, hadn't had the same scrutiny as some of our other broad reaching dependencies. One of our dependencies is block. Block is a state management library in Flutter that's commonly used. We also use freezed, which is a code generation package that's also very commonly used. Provider is another one that we used across our code base. And for all of these, we had internal engineering discussions on best practices of how to use them, whether we should still be using them, as well as having documentation written out around patterns and use cases for how they should be used. For Mockito, we hadn't really done that. We just put Mockito in, told our engineers run with this, and across several engineering teams, our testing patterns diverged down different paths, leading to poor quality tests and inconsistent tests. So with mocks sort of riddling the code base, we had this like weird solution of when we were trying to transition out of using Mockito, that our transition team would have to go into each of these engineering teams' code bases and find out, okay, how are they using mocks? How can we switch this up to be able to fix it to be better? So this is just a quick screenshot I grabbed from a commit of March of 2021, grabbing just like how many mocks were being used in our code base. Mind you, I would argue probably not even a third of our app had been transitioned to Flutter at this point. Since then, we're probably up to like 90-ish% of our app in Flutter. And we had around 647 instances of mocks being declared across our code base. And that's just the declaration of being able to use them, not the instances of mocks being used across 280 test files. That's a lot. We've pushed it down since then. And we've, as I said, we've developed much more of our app into Flutter since then. The second issue we ran into were hidden single responsibility principle violations. This was actually what inspired me to make this talk, because we had this monolithic code that was sort of hiding with the usage of mocks. So in the world of mocks, when you're writing your test for your class under test that relies on X dependency, when you have that mock, you only need to override the methods that your class under test cares about for the purposes of that test. So say we have our goal service from earlier, and our class under test only cares about fetch goal. No matter how many methods are defined on the goal service, the test is only going to be viewing fetch goal. So as develop continues, single responsibility principles or violations are going to get into the code base. Code review is not perfect. We mess up, we slip up, we're humans. But when we were writing our tests, the mocks were hiding the fact that there were these principal violations because we only had to worry about the methods that we cared about. As we began to do this transition out of into null safety, we began writing fakes in the place of some of these mocks. And when you write a fake, you are implementing the class that you're trying to depend on, meaning that you have to override all of its methods. So in our goal service example, if goal service had fetch goal and fetch goal summaries, but also had 3 other unrelated methods, when writing the fake, you would have to override all 3 of those other overridden methods and become really apparent to you that, hey, this goal service is doing too many things and is a bit monolithic. So as we began to write more of these fakes, we were able to spot out these locations in our code base and break down those classes that were too large into their separate responsibilities. And the mocks that were previously there were just hiding away that violation. So this is an embarrassingly recent screenshot of that goal service code. As you can see, we have our fetch goals and fetch goal summaries, but we also have a fetch goal image, which is tangentially related to a goal, but also fetch goal available portfolios, which is completely unrelated to a goal at this point. It's more of a portfolio concern and should probably be in some portfolio related service. But it was here on the goal service and got slipped in at some point. In the world where we were testing with mocks, if we had a screen that relied on the goal service, it might only override fetch goal. And in code review, we wouldn't see this. When we switched over to fakes, we were able to see whenever you tried to make a fake for the goal service, I'm overriding these unrelated things. We need to break this down into its smaller components. The last issue that we ran up against was just our testing paradigm altogether. In the world of using mocks, we sort of fell back on this crutch of their verification behavior and tested our code in a more white box way, meaning that we were able to reach in and see what the class under test was doing and test its implementation rather than testing its behavior. By testing the implementation, we weren't testing what external consumers of that class were actually caring about. For example, if we're testing a screen and we're testing its implementation, the user's not going to see that. They're just going to see, I'm interacting with it in this way. I want to see certain visuals based off that response. If I'm making a service for another team, they're just going to expect, given this set of inputs, I want this return value, not that this service is calling this other service in this way at this time. So as we shifted towards fakes, we began testing the behavior more and testing in a more black box way. Black box being the opposite of white box, where you isolate your class under test with no visibility into it and only verify outputs based on inputs. The one sort of exception to this is verifying side effects that we came across. We classified side effects as a form of output of a class. So we went over screens having visual feedback to a user. We went over return types from methods to another consumer. Side effects are things that happen as a result of our code that don't really have any visible effect on the consumer of our code, but have an important effect elsewhere. So this could be logging, doing analytics calls, or even just like doing creating records on the database in the back end that don't have any visual effect on the front end. So for these cases, we still do allow a more white box pattern where we allow our testers to reach into the class under test to verify that side effects have occurred. So what was our path forward out of these problems? Before saying that we completely ditched mocks in favor of fakes, I do want to say that our fakes are still important. I forgot my analogy, but oh well. Mocks are still important. We still have our little dude up there. And they're useful in certain situations still. One situation of that is for mocking external libraries that you can't easily wrap. An example that we have in our code base with our dependencies is block. Block is a pretty big unit of, it's still a single responsibility, but it does a lot of things within that responsibility that make it pretty difficult to fake. So fortunately, they provide their own mocking library associated directly with block so that we can mock our business logic components for our screens and test our screens in isolation from the business logic. The other place, as I mentioned earlier, is for when those side effects need to be verified. Side effects still being an output of your class that you want to verify, but not having the means to do that when you're using a fake or a stub. So where do we actually use fakes now? We use fakes to fake out the external boundaries of our app. Those boundaries are primarily the network as well as the boundary with the native app. For being a add-to-app Flutter app, that means that we still have portions of our app that are still from that pre-2020 native code base. In our Flutter world, we can launch features that are in Flutter. It'll pop whatever view component you need on the native side, and then push back to Flutter whenever you need. We have a feature around this that's the native feature manager. It allows us to do that, and we just fake that and have an easy interface for devs to be able to override, for X feature, I want these outputs from that feature. The other side of that is plugins, which are Flutter's solution for full-on Flutter apps to be able to dip into native whenever they want. There's plenty of these out on PubDev, which is Flutter's publishing package library, for things like permissions, the camera, anything native related that you need to do that you can't do in Flutter, you can do quick dips into native for. We've even written some of these for third-party SDKs because Flutter is such a young technology. Many providers only provide an Android and an iOS SDK. So we make a thin wrapper around that with a plugin, and then within our app, we can have a service wrapper that's just calling into that plugin, which is fakeable for the purposes of our tests. For our network layer, one of our principal engineers built out the Charlatan package that allows you to have fakes for a DO HTTP client, which is the client that we happen to use. And it allows you to say for any given path, network request path, I want to give this response. You can pull out your query params, your body, even your headers, and vary your response based off of that. And that has allowed us really great control over that boundary as well. For the classes that we have internal to our app, for when we're trying to write fakes for dependencies for more unit level tests, We've just been swapping one-to-one mocks for fakes at a test-by-test level. This is still a work in progress. As I said, we still have several mocks in our code base that probably still could be used to be updated, not necessarily needing the exceptions that we mentioned before. But the work there now is less about swapping over, but also pulling those into shared locations and transitioning them from being more so stub behavior and shifting to more so fake behavior, so that our tests are testing in a more production-like environment than testing with just stubbed values. The other thing to do there is to have those shared fakes have visibility across our engineering work team. Because we have several teams working on our mobile app simultaneously, if there's a service or class that several teams use, we want to have that shared fake be visible to all of them. The last thing that we've been doing is testing at broader than a unit level with these fakes. This has been one of the most impactful outcomes, as it has increased our code confidence overall. One way that this has been done is teams testing screens as a full unit. I mentioned earlier when we were talking about mock block that our pattern has been to test a block, which is our business logic component, sort of our state management, in isolation, and then test our screen with a mock version of that block. That's great for having that isolation between like your logic and your visuals, but it can break down when you're testing your visuals because you can provide whatever state you want for that mock block. And that could technically not be a real state that a user could ever get into, or a sequence of states or events on that block. They can be essentially not possible, meaning that you think that you have code confidence, but you're maybe leaving out real user situations or testing for situations that a user would never get into. So what some of our teams have begun to do is test at a full level where they'll inject the entire dependencies needed into the screen, and the screen will build a real block alongside that and test both the visuals and the business logic as part of one big widget test. The other place that we've done this is testing for full features. This is something that I've worked on quite a bit, where we wanted to be able to have more integration-y tests in our system, but Flutter's built-in system for integration test, which was for a long time Flutter driver, is now a package called integration test, has to run on a physical device and interact with a real network. So these are things that aren't really possible in local dev for a local dev to do frequently, and it's definitely costly to do in CI as well. So in order to maintain code confidence for regular day-to-day development, we wanted to be able to write widget tests, which are Flutter's form of UI tests in the, Jetpack Compose world, and be able to run those across full features in our app. So how are we able to get that to work? We had these system level fakes that I mentioned earlier, and we can inject those directly into the app layer, as well as injecting the feature directly into the app layer, such that the app can set up all the dependencies, start the feature up running, and then we can interact with the feature as if it were any old widget in a smaller version of a widget test. This has allowed us to step straight through features, verify that all the behavior is present, that we can complete the feature, but most importantly, it allows us to test these from top to bottom, meaning all the way from user interaction down to the network layer and the native layer, and all the way back up to the visuals that the user sees. So what's next for us as we continue down this pathway of improving our testing? As I mentioned earlier, we're going to continue improving the shareability of those internal fakes for the systems that aren't these sort of like external boundaries. The next step is, as we go through and revisit some of the older code in our code base through normal product development, we're going to be updating those tests where relevant to use fakes. And as we do that, we're going to be on the lookout for those monolithic classes that may have hidden away underneath those mocks. And as we transition to fakes, those will be apparent, and we can go through, break up the monolithic classes. So not only are we improving our tests, but also improving our code base along the way. That's all I have for today.